Let me give you another example of Bayes' theorem. So this here is Bayes' theorem, and the problem is 30% of a population has a certain virus, and when you have that virus and you get tested, it would be, the machine would be 90% correct. So there's a 10% chance that it would be a false negative, and if a person doesn't have a virus, the machine might still register you as being a positive. So here the machine is wrong because you don't have a virus, and yet the machine says you've got a virus. So the machine could be wrong. So this is the information that you've been given. So you draw a map, like which I've done for you right here. So if 0.3 is a probability of you having a virus, then you can say that 0.7 will be no virus. And if 90% of the time the machine's correct, then there's a 10% chance that it would be wrong because you've got a virus here and then you tested negative. So the machine here is wrong. So here, the machine here is wrong 20% of the time. If you have no virus here and then you have a negative here, so this must be correct. The machine here is correct. So this would be 0.8 here. Okay, so let's do this without using Bayes' theorem, and then I will show you how to use Bayes' theorem. So really, it boils down to you trying to work this out. Given that you've tested positive, so given the vertical lines, given that you've tested positive, what's the probability of you having the virus? So let A be the virus here. So virus. So given, so a random person is selected, and this person here gets tested by the machine, and the machine says, oh, you're positive for that virus. What's the probability of this person having the virus? Because you could have no virus and the machine says that you're positive. So there is always this mistake here. So we are trying to find probability of, given that you're positive, what is a probability of you having the virus? So let's work this out. To work this out, you would get, remember, if you want to know this, let's go back to this Venn diagram. Probability of A given B. So given B has occurred, so you should be looking at this circle of 5 here, and the probability of A happening would be A and B. So that would be 2. So you would get the part, which is this thing here, divided by the whole thing here. So we're going to do this for this diagram here. So hang on. So given that positive, well, you testing positive would be you going down this branch here. So this is a good branch. This is a good branch. This here is a bad branch because it's negative has occurred. You want positive. So this here is a bad branch. This here is a good branch, this one here, because you want positive to occur. This here is a bad branch because negative has occurred. So the two good branches here and here, what is the probability? So hang on. So the whole thing, just like up here, the whole thing would be this branch or this branch. So it would be this times this, so that would be 0.3 times 0.9, and then plus it could be this branch here, which would be 0.7 times 0.8. So this is a probability. This is the whole thing of it's being positive. So here the machine's testing positive. So that covers. That's similar to A given B, where B is a whole thing. So this here is a whole thing. Now you need the part. The part would be, given that is positive, and you want to know the probability of the virus, so you must go down this branch here. So this is the part here. This is a part here. So this would be 0.3 times 0.9. So you need this branch divided by the combination of this branch and this branch. So that's this whole thing here. So this is your final answer. Now let's use Bayes' theorem. So Bayes' theorem says A and B in our case will be, given a positive, what's the probability of us having a virus? So that will be that would be the whole probability of B. So remember, B is like positive. What's the probability of you being positive? It would be this branch and this branch. So let's look at this one here. 0.3 times 0.9, 0.9, and then it could be this branch here. So that would be 0.7 times 0.2 times 0.2. Now let's read Bayes' theorem now. This block here, so what is this block here? Given that the virus has occurred, what is the probability of you getting a positive? So when you read this, given that the virus has occurred, so if you're the person who has a virus, because it has already occurred, if you have a virus, what's the probability of you testing positive? Well, it would be 0.9. It would be this thing here. So that would be 0.9. Now let's read this. What is the probability of A? Meaning, what is the probability of you having the virus? Well, looking at this bit here, the probability is 0.3. So that would be times 0.3 times 0.3, because 0.3 is a probability of you having a virus. 0.7 is not having a virus. So this, using Bayes' theorem, led us to this. Using the diagram would lead us to this. You can see that they're exactly the same, because look, 0.3 is here, 0.3, 0.9, 0.9, and this whole thing here is a probability of you getting a positive on the whole thing, of you testing positive. Okay, so these two are exactly the same. Using this method, you can actually understand where all these what this means and what this means. Okay.